There we go. All right, can you hear me better now?
Yeah, you should be all good.
All right, sweet. Um, so we look at block C. That is the maintenance category. We don't really need to know about that. That's going to be for the maintenance controllers because that will determine how fast they have to fix this. That's not going to really apply to us as dispatchers. Block 2, that is the number installed. So for instance, at this MEL, we are looking at air conditioning packs. There are 2 air conditioning packs installed. Block 3 is going to be the number of required. So for this MEL, it's saying that on the aircraft, there are 2 AC packs. You guys learned that when you were talking about systems. We have 2 AC packs. Only one of them has to be functional, and we can fly with this MEL. Block 4 is the MEL number. So for instance, when you are dispatching a flight, when you pull up the flight, it will list an MEL number. It's not going to give you on your flight plan the entire MEL. It'll just give you that MEL number, and then you'll go to your MEL manual, and this is how you will look it up. So for the AC pack, it is MEL 21-51-1 alpha. Block 5 is the remarks section, and that's where our limitations and restrictions are going to be. We need to pay attention to that because there could be limitations in there that would change how we need to plan this flight, how we need to dispatch this flight. So if we read through here, we see that the right pack may be inoperative provided the right-hand pack is selected off. We don't care about that. That's for the pilots. Operations are conducted at or below flight level 310. That's the one that we're going to want to focus on as a dispatcher. With an AC pack in op, it limits us that we can operate with only one working, but we cannot plan the flight above 310. Now let's think about what we learned about AC packs. Who can tell me what the AC packs are providing for the aircraft? Trevor.
Air for the cabin and pressurizing the aircraft.
Correct. It's maintaining our air temperature, and it is providing pressurization for the aircraft. So thinking about that, why do we think there would be a flight level restriction if only these was working? Christopher.
I'm not sure. I think you're calling on me, but just because you wouldn't be able to pressurize above a certain altitude, I think it's 1310. Okay.
We will be able to pressurize, but because we have now lost our backup system, we don't want to be that high, because if we were to lose the remaining pack, we would no longer have a backup. And now we'd be in an unpressurized state, and we'd be putting the crew and passengers at risk. So for the safety of flight, we're not going to plan above 310. That way we can safely descend to a suitable altitude if we were to lose the remaining AC pack. So that remarks block, That's where we're going to find any limitations that we need to plan for as dispatchers. Going through the rest of the remarks, RAM or SOV is either verified operative or deactivated open. Again, not something that we're really needing to worry about as dispatchers. And then operations are conducted in accordance with the AFM, supplement operations with airplane systems inoperative. Again, that's going to be something for the pilots to look at. Block 6 is the maintenance procedure. That is going to be telling the mechanic on the ground what they need to be doing in order to apply this MEL. So what would happen is, the pilots would call into maintenance control and say, hey, I'm getting an indication that the right-hand AC pack is inoperative. Maintenance control would send a mechanic out to the aircraft. The mechanic would look at it and they would say, yeah, for whatever reason, the right pack is inoperative. Maintenance control would say, okay, we are going to apply MEL 21-51-1 alpha, follow the procedures in the MEL. The mechanic would follow these procedures, and then the MEL would be applied, and then we could operate. So in this case, none required if RAM Air SOV is operational. There is no maintenance procedures. If required, deactivate the RAM Air SOV open per MEL 21-52-1 alpha. And then lastly, block 8, which for on here is labeled 5 again. That'll need to be fixed. With one pack inoperative, flight crew will operate RAM Air SOV, must be verified open, and the operational requirements addressed in remarks, exceptions, column above, item consistent performance adjustments, which will be made by dispatch. So essentially, again, it's just reiterating, we can operate with the right-hand pack inoperative as long as we follow the procedures in here. For us as dispatchers, the one that's really going to be pertinent to us is the flight level restriction. We cannot plan this flight above flight level 310, 31,000 feet. Which, who remembers what the standard service ceiling of the CRJ 700 is? Jaden.
Well, standard service ceiling of the 700 is 41,000, I believe.
Yes.
Good luck getting it up that high, but I just wanted to say, yeah, another reason why we have those altitude restrictions is if we think about it, right? We have 2 air conditioning packs. We only have 1 that's operating, right? So we're doing 1 pack is doing the job for 2. So again, that handles the pressurization. The higher we go up in altitude, the more pressure we put on our 1 functioning system, right? So by having an altitude restriction, we're essentially taking off some of the pressure from that 1 working system so that we reduce the likelihood of an additional failure with our 1 system operating. So that's all it is, right? But these restrictions were taking off pressure from the other systems within that so that, again, there's less likelihood of failure. Because if we had that 1 system, basically the higher we go up, the harder it's working and the more likelihood that that other system will also go out. So that's just the kind of the other thought process behind it as well. So
Yeah, that's a very good point. All of these systems are rated to function by themselves, but obviously, as Jaden was saying, that does put a lot more strain on them. Just like our airplane can fly with only 1 engine, but that engine's going to have to do a lot of work and puts the aircraft at significant risk if it is operating by itself. Same thing with the AC packs. If we're putting that much pressure on a single pack, the likelihood of failure increases, the wear and tear on the system increases, which makes it more likely to fail in the future, even once they get the remaining pack fixed, which reduces the safety margins and dispatch reliability of the aircraft. Thank you, Jaden. All right, the time is 6:22 Mountain Time. Let's go ahead and take our first break. Let's be back at 6:32. Ted, do you have a question?
No, sorry. I was trying to give a thumbs up and hit the wrong button.
Oh, all right. No problem. All right, welcome back. Any questions you guys thought of while you're on break? So again, this is what in yes, Brian.
Um, so I assume then the pilot also receives a list of the MELs. Is that and he has a manual in the cockpit? Is that right? Just because for some of these operating procedures, so he knows what to do and stuff.
Correct. And the MELs will be attached, or they will be part of the dispatch release. So they will see all of the MELs that are on the aircraft, and then they can refer to those specific MELs so that they can see the restrictions and their operational procedures with all of those MELs, or with any MELs they have. They'll also usually be placarded, meaning there'll be like a sticker in the aircraft if a system is on MEL. This one does not include a related placard, so there may not be one for this, but a lot of times there'll also be a placard on the flight deck if there is a MEL on a system.
Okay, thanks.
It'll also be included in the aircraft maintenance log, which they have to sign off and review before each flight. All right, conflicting MELs. Yep. So when we see these MELs, we have those restrictions, they have those requirements of operations. Some MELs have requirements and restrictions that are not compliant with other MELs, even if the flight would otherwise be legal to dispatch. It's always important to consider the operational requirements in an MEL to ensure it can be applied with existing deferrals. So, for example, if we had an MEL for the anti-skid system, which if we remember the anti-skid system helps the aircraft brake, that MEL may have in it that it cannot be applied if there is also an inoperative thrust reverser, which helps us brake, or if there was an inoperative ground spoiler, which helps us brake. So when we have different systems that are related, a lot of times MELs on those systems can't be simultaneously applied. And when that happens, when we have two MELs or two systems on the aircraft that are not functioning, but the maintenance procedures say that one system has to be working for the other system to be broken, we can't have both those MELs and be able to legally dispatch the aircraft. If that were the case, we would have conflicting MELs. And when we go through later tonight, we'll look at some of these specific MELs and we'll see in there what this looks like, where it specifically says we can't apply this MEL if other systems related to it aren't working. So let's say we did have an MEL on the aircraft for, well, let's just use the example that I've already brought up for the anti-skid system. And in that MEL restriction, it says both thrust reversers must be functional. And then the maintenance controller comes over and says, hey, you have this aircraft, just letting you know that it has a broken thrust reverser now. What would be our options in that case where we would have two MELs with conflicting restrictions? From a dispatch standpoint, what options might we have to be able to dispatch that flight? Yeah, Trevor says change aircraft. Absolutely. If we have an aircraft that has maintenance restrictions that would not make it suitable to legally dispatch, get a new airplane. What are some other options we might have? Brett.
Would it be possible to try and get the issue resolved with a mechanic or something?
Yep. So Brett, and then I think someone put in chat as well, saying on the same kind of theme, give maintenance time to fix the airplane. So if we could get one of the issues resolved, either if we get the anti-skid system fixed or if we could get the thrust reverser fixed, we no longer have that conflict in the MEL, and we can now legally dispatch. Now, if we go back to our FARs, we cannot get it fixed because we're in an outstation, and we can't get a tail swap because there just isn't one available. What's our last resort? Yeah, Brian said cancel the flight. So fix it, swap it, or cancel it. Those are our big three when we come down to maintenance issues. The first thing that especially maintenance control, and then usually someone in my role, like a duty manager, is going to push for is going to be, can we operate with the existing MELs? If the answer is no, then it will be, okay, can we fix something? Then if the answer is no, then it'll be, all right, can we get a new airplane? And if the answer remains to be no, then we start talking canceling the flights. And then I get to call up Delta and say, hey, we have no other options. We're going to have to cancel this flight unless you guys have a plane or one of the other regional carriers has a plane and a crew that can operate this flight. Or we might get a call from Delta that says, hey, SkyWest has a broken plane in Roanoke. Do you guys have a plane and a crew in Atlanta that you could send to operate the flight for SkyWest? This is one of the no-go items that we commonly see on practicals. The DAID will give you, the student, a example dispatch reliefs, and there will be 2 MELs applied to the aircraft that have a conflict, and both cannot be applied. If that is the case, if, for instance, you get conflicting MELs on your dispatch release, you'll want to bring that to the attention to the DAID to say, hey, on this release, you gave me an MEL for a thrust reverser and an MEL for a anti-skid system, but in the MEL descriptions, they say they can't be applied together. So I wouldn't be able to legally dispatch this flight. And then the DAID would ask you something along the lines, all right, so what are your options if you have conflicting MELs? And that's where you would bring in that answer that we just discussed. Well, my options would be to try to get one of them fixed, to try to get a new aircraft, or if I was unable to get this resolved and I was unable to legally dispatch this flight, we would have to cancel the flight. At which point, once you provide a satisfactory answer to the DAID regarding how you would handle with a conflicting MEL situation, the DAID will usually say something along the lines of, all right, that was a good answer. In this case, we're going to fix one of them. Let's say that the thrust reverser got fixed. You can continue planning your flight. But conflicting MELs, because that is a legal to go item, when we go through our legal to go checklist, MELs is one of those legal to go items. Conflicting MELs is commonly an issue that will be presented on a practical exam. So knowing your resolution steps, getting it fixed, replacing the aircraft, or canceling the flight is going to be something you should remember when you're going into your practical. And we'll practice this when we're doing our practice flight plans in class. Brian, you have your hand up.
How common is this in the real world? I mean, I would think they have software that would kind of help try to prevent these kind of things. You know, planes being assigned to flights where they have conflicting MELs.
As a dispatcher, you won't usually see conflicting MELs applied to the aircraft. I have seen it in real world application. It's rare because, like you said, there are essentially You might see it, but it would not be on. How do I want to word this? A lot of times, if you see that, it's because that flight, the aircraft is either actively getting fixed, but both MELs are applied because they have to do the write-up in order to do the maintenance procedure, or because it was applied and they are actively in the process of trying to replace the aircraft. Very rarely will you see it where no one is aware of the situation and you have to bring it to somebody else's attention. But it is a legal to go item, so it is something you have to check, because there is that rare chance that it was missed by the system and it was missed by the maintenance controllers, and it comes across your desk and you're trying to dispatch this flight and now you have conflicting MELs and you're not legal to dispatch. More commonly, and we will see this when we start going through those example MELs here in a bit, more commonly you will get an MEL with a related restriction that you cannot safely operate on your flight. And we'll look at some examples of that as we go through the example MELs as we go through the rest of this class. But it is a possibility in the real world. I have seen it happen. And it is a definite possibility on your practical. Good question. Other questions regarding conflicting MELs? And again, we will address some of these more as we go through more example MELs. All right, let's look at some example system issues that would impact our flight operations. Basically, what are some example MELs that us as dispatchers would need to be aware of because they're going to impact the way we plan flights? There are a lot of MELs. I mean, a lot of MELs. And at the end of this class, if we have time, I'll pull up the MEL manual for the CRJ 700. A lot of these MELs we'll see on our flight release, and we'll look them up and say, oh, that has absolutely nothing to do with me as a dispatcher. I mean, it could be something like the galley oven doesn't work. That would be an MEL. Or a tray table is inoperative. That would be an MEL. Or some other system on the aircraft that might impact like some procedure the pilots have, but wouldn't really impact us dispatching. Like, for instance, I'm trying to think of a good example here. If the first officer's flight director was inoperative, the procedure might be ensure that the captain's flight director works. If it does, I mean, that's the full stop of what we would need to worry about. There would really be no major impact on us. A cargo bin door latch, wouldn't it be something that you as a dispatcher would really be involved with? Or like the CRJ 900s we have at Endeavor, they have a power assist on the passenger door because it's really big and heavy. If that doesn't work, that's not something you as a dispatcher would need to worry about. That would be something our sector supervisors are calling stations and letting them know, hey, by the way, the power door assist doesn't work on this airplane, so have a couple guys out there to help you lower the door. But as far as dispatchability of the aircraft, that's not going to affect legal to go. That's not going to affect anything that we as dispatchers are looking at. Does it affect the operation of the aircraft? Is it a system on the airplane that the manufacturer says is there and doesn't work? Yes, so therefore, if it doesn't work, we have to have an MEL to say that it's not working, but we can still fly, but it doesn't really pertain to us as dispatchers. What we're going to look at here are some of these systems that when they don't work, do impact the way that we plan flights, the way that we dispatch flights, and may impact whether or not we can even legally dispatch that flight if that MEL is on there. And this really comes down to why we spend a week on aircraft systems. Now, I don't expect any of you to have an understanding of these systems the same way like an engineer or a mechanic would. The pilots don't even have that level understanding of these systems. But understanding what they do and how they work from a general conceptual basis helps us understand that when one of these components fails, what impact it has on the flight. Like we were talking about with that AC pack MEL from earlier. Do I expect you to know how an AC pack operates from a mechanical standpoint? Absolutely not. Does the DATE expect that? Absolutely not. What the DATE is looking for and what you will apply for real-world dispatching is understanding that the AC packs control our climate control and they control pressurization. So when they're not working, those functions of the aircraft are less efficient. And then we have limitations. So that's why we spend time talking about these aircraft systems, even though you might say, why do I need to know that there are 3 hydraulic systems with 2 pumps per system and the emergency backup system is the 3B pump? Until you get an aircraft that has a deferred 3B pump that you can't fly, and you're like, well, if I have 5 other hydraulic pumps, why do I care if the 3B pump is not operational? But then you remember, oh yeah, the 3B pump is the one that works if I lose all other electrical power. So if the 3B pump doesn't work and I have a complete electrical failure on the aircraft, I no longer have hydraulic control of any of my flight surfaces. So that's why we want you guys to have an understanding, generally speaking, of what these systems do and how they impact the flight, so that we understand as dispatchers when they're broken, what effects that's going to have on the way we need to plan the flights and how the aircraft is going to handle. And really, from a dispatch perspective, again, we're not looking at things like seat backs. We're not looking at things whether or not the sink in the lavatory works. Those don't really matter to us. What we are looking at are going to be safety critical items, items that are restrictive to our flight, and items that have limiting performance factors that would impact our flight. Those are going to be the big ones that we're going to be focusing on as dispatchers, because when we're planning these flights, when we're looking at our legal to go, our operationability of the aircraft, you know, how we need to route it, what flight level we can plan, how much fuel we need to put on the plane. These are going to be the items that impact that. The items that we as dispatchers need to be focusing on. Safety items, restrictive items, and performance limiting items. All right, so we have looked at this one a little bit. AC packs, this is the one that we used the example of earlier. But let's go ahead and take a look at this, and let's ask ourselves these questions. First off, AC pack. What is the restriction? Brett.
You gotta operate below flight level 310.
Yep. Operations are conducted at or below flight level 310. Again, we talked about why. Why? Because we have lost our backup system. As Jaden pointed out, that puts additional strain on the remaining system, and we do not want to risk failure or the consequences of failure of the remaining AC pack. Now, outside of these direct limitations that are put on the aircraft in the MEL, what are some other, what are some other considerations that we might want to think about if we're dispatching an aircraft with an inoperative AC pack? Brian.
You know, if it's the middle of summer, you might be dealing with a pretty warm cabin, so temperature might be something to keep in mind.
Absolutely. A lot of times in the summer, when we have inoperative AC packs, the airplanes are really hot. You might get a call from a captain saying, hey, I want to run an engine for a bit so I can get the cabin cooled down. Or a captain may straight up refuse the aircraft if it's too hot. You might be working with stations or might want to bring this to the attention of a system controller or a sector supervisor or a tail router, whatever that role is called at the company you're working at, and say, hey, I've got an aircraft going to Las Vegas with an inoperative AC pack. Can we make sure that they have gate air conditioning available that they can put on that airplane? Because I'm not going to be able to run the APU at the gate and keep the aircraft cool with a single pack inoperative. I was once on a SkyWest operated CRJ 200 flying from Hayes, Kansas to Denver in August when it was 108 degrees outside with an AC pack inoperative. That was the most miserable 40 minutes of my life. So yeah, inoperative AC pack, especially in summer, is going to be a big deal because we cannot, again, with one operating, we can safely operate, but it's not as efficient, and we're going to be putting a lot more strain on it to try to get that aircraft cooled off, especially if it's the pack that goes to the main cabin that's broken. We say in the summer, if you have an inop AC pack, you either have unhappy passengers or unhappy pilots because one AC pack feeds the cabin, one AC pack feeds the flight deck. I just saw a hand. That's not what I want. But I didn't see who it was. Who has their hand up? Sorry.
It's me, Mohammed. So what
Sorry.
ended up happening? Because AC pack went out, right? And you said there needed to be basically AC connected at the gate, which is usually a normal procedure. So what ended up being different, and what made it a miserable 40 minutes that you had to, I guess, just run around and make sure that the flight went out safer?
They did not have. I mean, Hayes, Kansas. It's a small regional airport. That route is an essential air service route. They didn't have an air conditioning unit on the ground, so we got on that plane and it was 108 degrees on that plane, and it never cooled off. We just sat in there sweating, fanning ourselves with the safety briefing cards.
Oh, that does not sound fun.
No.
Okay.
All right. What would we be able to operate if both AC packs were NAPA? Yeah. So if we refer to our installed and required block for this particular MEL, we could not operate with 2 and up because it says 2 are installed, 1 is required. Now, very likely there is a different MEL that says 2 installed, 0 required. However, its operational limitations would be flight is operated at or below 18,000 feet and no passengers are on board. You may have to dispatch a maintenance repo flight for an aircraft that has 2 inoperative AC packs, and that would be the restriction. You would have to stay below an even lower flight level because now they can no longer pressurize the aircraft at all and would not be able to operate with passengers. So in that case, it would just be a maintenance reposition flight. You're just flying it back to a maintenance base to get it fixed. You will have to dispatch maintenance repo flights where there's nobody on board. The airline is just moving the airplane someplace to get fixed. A lot of times this will be pressurization issues, landing gear issues, things like that. Actually, I think it might be at or below 15,000. All right, questions about AC pack MELs or AC packs in general? All right, next example. Maybe. Okay, so here is exactly what I was talking about. AC packs, and if we look at the top right corner, we have 2 installed, 0 required. So in this case, we have operations are conducted unpressurized at or below 10,000 feet. At or below 10,000 feet, and extended overwater operations are prohibited. So, I was wrong. There is not a passenger restriction with this. However, there is that 10,000 foot flight level restriction. Realistically, in practice, an airline is not going to dispatch a passenger carrying flight with 0 AC packs functional. While they could, realistically, that isn't going to happen. Simply because, as previously stated, that is going to be very, very uncomfortable for the passengers because there's not going to be any functional climate control on that airplane. So it could be really hot, it could be really cold, and there's really no way to control that without the AC pack. And at 10,000 feet, that is going to have an extremely prohibitive fuel burn. We fly at high altitudes because at high altitudes, the jet engines are more efficient. At lower altitudes, the jet engines burn a lot more fuel. And when you guys actually get into flight planning, you'll start seeing those significant increases in fuel burn at lower altitudes. So the fuel required to operate a passenger carrying flight at or below 10,000 feet would be extremely prohibitive. So from a realistic standpoint, from an airline operation, you will likely never dispatch a flight with 0 operative AC packs. But we do see here there is a separate MEL that would apply where we could dispatch this airplane, again, probably just on a maintenance repo, with no functional AC packs. Oh yeah, and procedures are established and used to ensure the cargo compartments remain empty or are verified to contain only empty cargo handling equipment, ballast, and or flyaway kits. So again, could not put any cargo on this airplane, so no passenger bags, nothing like that. The only thing that you can have in there would be, again, cargo handling equipment, so that'd be things like cargo nets, and then ballast, which you would use for weight and balance. If you needed to add ballast to either the forward or aft cargo bin, which ballast is just sandbags. So again, highly unlikely that this plane would ever operate on a passenger carrying flight, but you will probably see this at some point for a maintenance repo. And we can see that we can legally dispatch this flight under these conditions. Now, the other thing that could happen if you do have some sort of maintenance issue on the aircraft that is not covered by an MEL or a CDL, and usually this comes with significant aircraft damage, you might dispatch a flight with something what's called a special ferry permit. And what that entails is the airline has reached out to, for instance, if you're dispatching an A320, the airline has reached out to Airbus and they said, this is the damage on the aircraft. This is the extent of the damage. You know, there was major bird strike damage to the nose cone of the aircraft. We have to move it to a sheet metal fab base in order to get it fixed. Can we get a set of operational restrictions outside of the CDL manual so that we can ferry this plane? And engineering would come back with those restrictions, and you could dispatch the flight with that special ferry permit stating, under these conditions that are not outlined, they are beyond what is covered in the standard MEL CDL manual. Under these conditions, you may dispatch this aircraft on a single flight from this location to this location on this date with this crew. But again, that would not be a passenger carrying flight. So with AC packs, we saw what it looks like if one pack is in op and what it looks like if both packs are in op. So we can see that there are multiple MELs that will pertain to the same system. And it could just be a difference of what on that system is broke, or how many of that system are broke, or in what way are they not functioning, that different MELs may apply to the same system. Bleed air is a big one like that, that could have a few dozen different MELs that are all just for the bleed air system, because it depends on what part of the system is broken, where along the system is it broken, how badly is it broken, what's impacted, and how restrictive are we going to be. And a lot of times maintenance control will come up to me and say, hey, we got this fault on the aircraft. We're hoping that it's just this issue and we can apply this MEL that has very minor restrictions, but you do need to prepare for if it's this other issue and we have to apply this MEL that has much greater limitations. And we see this here. You know, crew calls into maintenance control, says, hey, we have an inoperative AC pack error on the flight deck. Mechanic comes back out and says, oh, look, both are broken. Now we have to go to 21-51-1 Echo as opposed to 21-51-1 Alpha. And we have to fly under these limitations as opposed to just at or below flight level 310. Any questions about that? All right. ACARS. All right. Don't ask me what the acronym means because I can never remember. But essentially what ACARS is, and you guys may have talked about this already, it is a text messaging system that allows the dispatchers and pilots to communicate with one another, as well as ATC and pilots to communicate with one another via text message, essentially. They have a screen on the flight deck that will display these messages. If you're flight following and you need to communicate something to the crew, you can ACARS them and just send them essentially a text message, and they can respond back with a text message really easily without ever having to try to establish any sort of verbal communication. It's a really useful system. We do a lot with it. So apart from being able to message the crew, ACARS is also what reports what are called OOI times, OOI, OOOI, which stands for out, off, on, and in. Those are the times that we use for tracking things like crew duty periods, tarmac delays. If we have a flight hour restrictive MEL where we can operate with this MEL but only for 10 hours, we would need to track that through OOI times. You'll also hear this referred to as block times. but ACARS is reporting that to the computer system so that they're automatically logged. There's certain maintenance functions that ACARS reports. ACARS will also, we can track things like when the engines were started, when the doors were closed, when pushback began. Depending on your airline, you may be able to see how much fuel is on the aircraft from ACARS reports, things like that. So, but just like any other system on the aircraft, it could go out. In fact, ARINC Radio, which is the primary ACARS provider for US-based air carriers, actually had a system outage today that impacted, I know it impacted Delta, I don't know if it impacted anyone else. But basically all of our planes lost ACARS functionality for about 30 minutes. But if it wasn't an ARINC radio issue, if it was actually the ACARS system on the aircraft, we could see an MEL like this. So again, looking at our MEL, here we have 23-22-1. Aircraft, oh, there's, hey, look, there's the acronym right there. Aircraft Communications Addressing and Reporting System ACARS. It's Category C, maintenance aircraft item. We have 1 installed, 0 required. Remarks and exceptions, if I could talk, may be inoperative provided alternate procedures are established and used. Note, any portion of the system that operates normally may be used. Maintenance procedures, none required. Placarding, and this is where we talked about earlier, for placarding, which means they just put a sticker on the airplane that says, hey, this is broken. Place M-74 Bravo near FMS control display. And then our operational computer procedure, monitor Atlanta radio. Note, UI times will not transmit during deferral. Flight crew must contact operations with UI times. Flight crew must monitor Atlanta radio or ARINC as applicable. Operations in Canada are not authorized. So if the ACARS system was out, the crew would know that they need to be monitoring either Atlanta radio or ARINC radio. Those are the backup systems that we use in order to make voice calls to the crew. So if the ARINC system was inoperative, so that we couldn't just text them when we needed to get a hold of them, the crew knows that they need to be monitoring their ARINC radio channels, so that if we as dispatchers need to communicate them, we're going to call them. We'll actually, as a dispatcher, you would call ARINC and say, hey, I need a radio patch established to this aircraft operating this flight, and this is its current location. And then ARINC would try to establish a radio patch to them. But if the crew doesn't know to be monitoring their ARINC frequencies, they might miss that you are trying to contact them. So the NOTAM is just saying, or the MEL here is just saying, hey, pilots, by the way, your ACARS doesn't work. You need to be monitoring your air-to-ground radio in case dispatch tries to contact you. Now, just because it says it in the MEL doesn't mean it's going to happen. When I was at Breeze, I was doing OJT with a new dispatcher, and we put on the dispatch release, we are going to do a practice ARINC call. Please monitor your ARINC frequencies in flight. In the remarks section on the dispatch release. So flight takes off, about an hour in. It was, I think it was Las Vegas to Florida, something like that. A longer flight. About an hour in, we think, okay, pilots are probably bored at this point. Let's go ahead and do our practice ARINC call. So I have the dispatcher call in to ARINC radio, request, hey, I need a radio patch to Moxie 111, currently flying over New Mexico. ARINC radio tries to establish the radio patch and then comes back and says, hey, we were unable to establish a radio patch with Moxie 111. We will continue to try and call you back if we are successful. Hang up the phone. About 5 minutes later, we get a call from ARINC radio saying, hey, we have established a radio patch to the flight. We do the practice ARINC call with the crew. By the way, and you'll go over this with OJT when you actually get to an airline. When you are on ARINC radio, all of your communication procedures need to be standard radio phraseology, which you'll learn. Anyway, we get through the ARINC call, hang up, all went well, and then we get an ACARS message from the crew that says, hey, next time you guys want to practice an ARINC call, let us know ahead of time. Like, we put it on your dispatch release. So just because something is on the dispatch release doesn't mean the pilots necessarily read it. But they're supposed to, because that is their procedure. Anyway, going back to this procedure, again, this is alerting the pilots that they need to be monitoring ARINC radio. This is also alerting you as a dispatcher. Don't try to ACARS this aircraft, because it's not going to go through. And if you're going to sitting here and then you go up to the duty manager and say, hey, I keep sending this flight ARINC messages and they're not responding. And then I'm going to say, well, did you read your MELs? Their ACARS is out. You have to call them. Don't be that guy. But the other big one on here is that the crew needs to manually report their UI times. Depending on the airline, either they will be calling into dispatch at the end of their flight, say, hey, here is my out time, here is my off time, here was my on time, here is my in time, or they'll be reporting that directly to the station. But you may want to alert the stations like, hey, by the way, this aircraft has an inoperative ACARS, so those times are going to have to be reported manually. That lets the station know that when the aircraft blocks out, they need to go in and manually input the out time. Otherwise, their information systems aren't going to update. Then they're going to be calling into you saying, hey, this flight still shows that it hasn't departed yet, but they left 20 minutes ago. And then you can tell them, it's like, yeah, I told you that their ACARS doesn't work and that you're going to have to manually input their times. So from a legal to go perspective, with the exception of dispatching flights to Canada, this isn't really going to impact whether or not we can legally dispatch this flight, but it is going to impact the way that we would interact with this flight. We couldn't send them ACARS messages, which is our primary method of communication with the flight crew. So we would need to know that any necessary communication with this flight needs to be handled through Atlanta radio or through an ARINC call. We would know that the aircraft is not going to report its UI times. So whatever the procedure at our airline is for manually reporting UI times, we need to ensure that is followed, because it is our responsibility as the dispatcher to monitor the status of the flight. If we remember going back to our FARs from last week, sole responsibility is monitoring the progress of the flight. Ensuring that UI times are reported is part of that monitoring the status of the flight, because that's how we know what stage of flight it's in. Are they off the gate? Are they off the ground? Have they landed yet? Have they gotten back to the gate yet? That is one of our responsibilities as dispatchers, to ensure that those times are recorded and kept track of. Also, to be monitoring our phones if we have a flight with an inoperative ACARS, because if they're trying to contact us, that call is going to go through Atlanta radio or through ARINC and then come to our desk. Questions about ACARS? All right, the time is 8. Oh, yes, Brian.
So, let's say if the ACARS was out, and let's say this particular flight, there's the possibility for some weather issues along the way. Is this a situation where you maybe want to have a actual conversation with your pilot beforehand, just to say, hey, I just want to make sure you guys are monitoring these other radios, because there might be a reason that dispatch would need to get a hold of them due to weather.
Yeah, if you saw something that you thought would or had the potential for definitely leading to information needing to be relayed to the crew ahead of time, that would definitely be a situation where it would probably be good to reach out to your pilots before the flight and say, hey, just so we're on the same page, with your ACARS inoperative, with this weather en route, I may need to reach out to you if there's any, shifts in where the weather is and changes that I think need to be made to your flight plan. So I just want to make sure that we're on the same page as far as monitoring AirInc, if I need to call you or you need to call me. And that's also something you might want to put in your dispatch release, on your remarks section, along the lines of severe weather en route. If I need to contact you regarding adjustments to your route, I will do so via AirInc radio. Just to throw this in front of them a few times, reminding them, hey, by the way, remember, monitor your AirInc radio because your ACARS doesn't work. All right, the time is 19:21 Mountain Time. Let's go ahead and take another 10-minute break. Let's be back at 19:31. All right, welcome back. All right, electrical systems. Obviously, there's quite a few electrical systems on our aircraft. Taking a look at this one, we have integrated drive generator, IDG systems, generators, generator control units, GCU. Category B maintenance item. Again, not really something that pertains to us. 2 installed, 1 required. Remarks or exceptions? Let's go through our questions. Okay, what are the restrictions associated with an inoperative IDG? Sam.
You need to be below flight level 320.
Okay. What's something else that we would need to consider as a dispatcher? Caitlin.
It says the APU generator is operated continuously throughout the flight.
Okay. Why do we care that the APU generator is operating continuously without the flight? What would we need to worry about that as a dispatcher? Brett.
Increased fuel consumption.
Yeah, increased fuel burn. The APU is another engine. It runs on jet fuel, so if we have to run it for the whole flight, we need to consider how much fuel it's burning for the whole flight. So if we have to run the APU constantly in flight, we do need to plan for the fuel burn for the APU for the entire flight. So with that consideration, if we had this MEL 24-11-1 Bravo for an inoperative integrated drive generator, could we legally dispatch this flight if we also had an MEL for the auxiliary power unit? Very good. And this one is a little bit trickier because it does not explicitly state in the MEL that the APU must be operative or that the APU cannot be inop. It just says we have to run the APU in flight. So it does require a little bit more thought on this one because it doesn't, spell it out for us in plain language saying, oh, by the way, you have to run the APU or the APU has to work. But because it does say in our restrictions that we have to run the APU, then we know that could not dispatch this flight if both the IDG and the APU don't work. Again, that's because both the IDG and the APU are electrical systems on the aircraft. We don't like it when multiple systems pertaining to the same functionality don't work. So if I don't have one of my generators, one of my primary generators, the IDGs, I don't also, we also don't want our backup system, the APU, to not work. And again, that flight level restriction 320, that is because our APU works better at lower altitude. It doesn't work as well at higher altitudes. So since we're going to be running it the whole flight, we don't want it to also fail. So we're going to be down at 320, even though the APU is capable of running at higher altitudes. Christopher.
We did talk about it yesterday, but as far as the air-driven generators, the ADGs, if we did lose, we didn't have an APU, we lost both the engine-driven generators, what does that give us? I mean, I know we did talk about it. I just wanted to just go over it again if we could.
Yeah. So the air-driven generator, the ADG, that's going to give you like the most basic functionality of the aircraft. It's going to be running the standby instruments on the flight deck. It runs the 3B pump, which goes to your ailerons, your rudder, your elevator, and your brakes. So pretty much the minimum systems required to be able to safely fly the aircraft is what you're going to have if you are on the air-driven generator.
Gotcha. So bad day.
Yeah, it's not great if the ADG has to deploy. I mean, luckily it's there if we need it, but we don't want to need it.
Is it basically land as soon as possible or land as soon as
Yeah,
practical?
no, if you had a
Okay.
full electrical system failure where you were on ADG power, that procedure on the QRH would be land at the nearest suitable airport in point of time. Quick FAR review. Who can tell me what makes an airport suitable? What factors make an airport suitable for the purposes of diversion? Brian.
Having the right kind of fuel available at the airport,
Okay.
having the proper maintenance available, I think, and then also being able to take care of passengers and baggage, that kind of thing. I don't know. I may be getting one of them wrong.
You're close. So, you were right about fuel type. You were right about passenger handling. And then Christopher put in chat within fuel range.
That's it. Yep.
So those are our three factors that make an airport suitable for the purposes of diversion. Correct fuel type, correct handling equipment for the passengers and the aircraft, and within fuel range. So you'll find the nearest suitable airport that meets those criteria, and you'll hopefully ACARS is working, because then you can just ACARS the pilot, recommend diversion to airport ABC. Here's the weather. Here are any relevant NOTAMs. Here's your fuel burn to that airport. All right, overheat detection. Let's look at MEL 26-14-1 Alpha main landing gear bay overheat detection system. What is our restriction? Michelle.
Operations are conducted at or below flight level 320.
Am I presenting the right page here? At or below 320.
Yeah, I think we were looking at the old one still.
Okay, let me make sure it's presenting the correct page then. You lost your network connection. Well, that's not good. That'll do it. It says I'm connected. That's weird. Meet kicked me off my other device, which was presenting the PowerPoint. So let me get that going again. Come on. All right, can you guys see the slide for overheat detection now? No.
Just your pretty face.
Aw.
There it is.
How about now? Perfect. Okay. Overheat detection. Sorry. MEL 26-14-1 Alpha, main landing gear bay, overheat detector, category B, 1 installed, 0 required. What is our restriction? Sam.
You can't take off into icing.
Yep, correct. No takeoff. Takeoff is not conducted in icing conditions. Now, here's the good question. Why? Because if we're worried about the main landing gear overheating, wouldn't, icing conditions reduce the risk of it overheating? Why would we not want to take off with this MEL in icing conditions? And I'll give you a hint. The reason is also in the remarks section. Trevor.
Yeah, it's like it says that the landing gear needs to be extended for a minimum of 10 minutes after takeoff, which
Correct.
would probably be problematic to retract it if it was.
Yep.
Nice.
So because if we look at point 3 in our remarks or exceptions, landing gear is left extended for a minimum of 10 minutes after takeoff. So thinking about overheat, main landing gear bay overheat detection system, if that wasn't functioning, why would we need to leave the landing gear extended for 10 minutes after takeoff?
In case of hot breaks, maybe? I don't know.
Yep, nope, you're exactly right. If the brakes are hot, we no longer have a system to tell us that they are hot. And we do not want to retract that main landing gear into the aircraft if they are overheating, because that could start a fire on the aircraft. And we don't want that.
Not sure why the
because
brakes would be overheated on takeoff, but I guess if you're doing touch and goes and somebody smoked the brakes, it could be, but
they could just be hot from taxiing to the runway. A lot of times that'll happen. Just the amount of braking required for the taxi action, if it's a really long taxi out or you're stuck in like a long line of airplanes, the brakes can get really hot just from taxiing to the runway. So if we no longer have that system to tell us that the main landing gear is hot, we don't want to risk retracting it into the aircraft if it is in an overheated state. So the MEL stipulates in order to ensure that the landing gear has a chance to cool off if the brakes were overheating or had, reached an increased temperature, we need to leave them extended for 10 minutes to cool off. Now, because we're leaving it extended, we can't take off into icing conditions because the landing gear is not one of the parts of the aircraft that we have anti-ice protection, which means it could, if we were taking off in icing conditions, there could be a significant buildup of ice on the landing gear, which is going to, again, produce additional aerodynamic penalties on the aircraft as well as increased weight. And if we were to then retract the gear into the aircraft, if it was coated in ice, it could cause damage to the landing gear systems. So do not want to have the landing gear extended for a long period of time in icing conditions. Now, what other consideration would we probably need to take into account if we had to leave the landing gear extended for 10 minutes? Ryan.
Looking at the operations procedure at the bottom there, it says that you can't be going more than 200 knots to retract them. So I guess you'd have to, watch your speed there in your first 10 minutes.
Yep. So definitely need to ensure that an appropriate speed profile is planned for landing gear extended. One other big thing that we would need to consider if we were flying with the gear down for 10 minutes. Speed is good. I like speed. But let's think about why we retract the gear to begin with. What that would do. Yeah. Drag and fuel consumption. There will be a fuel penalty applied as well along with this MEL, because you're going to burn a lot more fuel during that first 10 minutes of flight because you're dragging your gear. Standard procedure is to get the landing gear inside the plane as soon as possible because it does generate a significant amount of drag, which requires a lot more fuel for the aircraft to be able to operate. So there will also be, along with that speed penalty, there will also be a fuel penalty. Depending on what your dispatch systems are and your airline, that might be automatically applied, or that might be something that is in the remarks section saying plan an additional however many pounds of fuel due to the necessity to leave the gear extended. Any questions about that MEL?
We lost the presentation. That was
Oh, dang it. Sorry about that. You see it now? All right. Let me know if it drops again, because I can't see on my end that it's dropping. All right, ground spoilers. Ground spoilers are part of the lift dumping system. Here we have MEL 27-65-1 for the inboard or outboard pair. 2 installed, 1 required. If one set of ground spoilers was inoperative, what restriction would we have?
Both the thrust reversers have to be operating.
Very good. Both thrust reversers are operative. This is one of those ones that would fall into the conflicting MELs category, because if we had this MEL applied as well as an MEL for the thrust reversers, or even just one thrust reverser, we would not be able to legally dispatch this flight because we would have conflicting MELs. And it just dropped again, I think. Yeah. Let me go reset my router real quick. I apologize for that. All right. Sorry about that. Starlink is great 95% of the time. The other 5%, it can be a pain. All right, as stated, our major restriction here is that we need to ensure that both thrust reversers are operative. So one or both thrust reversers could not be inoperative and us dispatch legally with one set of ground spoilers being inoperative. What's another restriction that we would probably have to deal with if one of our sets of ground spoilers was inoperative? Thinking about what the function of the ground spoilers is, how else might this impact the way we dispatch this flight? And might limit what we can and cannot plan. What do the ground spoilers help us do, or help the plane do?
It shift the weight onto the wheels
Which allows it to do what?
to brake faster.
To brake faster. So if I had a flight that I was dispatching to Key West with its glorious 4,500 foot long runway, and the ground spoilers were inoperative, would that be concerning to me? Yeah. So likely if we see a deferral for the ground spoilers, and this one, it is mentioned in the MEL block, though not as directly. We can see that in the operating procedures, note the operation requirements addressed in the remarks or exceptions column above item 6 consist of performance adjustments which will be made by dispatch. So when we do what is our takeoff and landing performance calculations, we will see a we'll see a performance restriction there that could look like either additional runway length required or a weight restriction if the required runway length is not available. So if we were going to a shorter runway, likely that flight would be weight restricted due to the landing requirements and the performance penalties associated with one set of ground spoilers not functioning, because we would not get that increased braking action due to the lift dumping from that set of ground spoilers. Also, there could be takeoff penalties because part of our takeoff calculations is the assumption that we have enough runway to stop if there was a critical system failure during the takeoff roll. Questions about that? All right, anti-ice systems. Again, there are a multitude of systems that could impact anti-ice. Let's look at the MEL 30-12-5-alpha. Wing crossbleed valve, category C, 1 installed, 0 required. What's our restriction? Correct. No, operations are not conducted into known or forecast icing conditions. So we cannot dispatch this plane if anywhere along the route from takeoff to landing there is reported or forecast icing conditions. Going back to our FARs, what is our definition of icing?
Degrees C or less and visible moisture.
Yep. Visible moisture and 10 degrees Celsius. So if that exists along our route, we could not dispatch this flight. And I, in my current role, I sit right next to maintenance control, and they will always turn to ask me, "Hey, could we dispatch this plane no icing?" And I mean, in the winter, it's almost always no, though. Really, we can get around it a little bit easier in the winter because it's a lot more cut and dry where icing conditions are and are not. Basically, in the winter, if you can avoid clouds, you can avoid icing conditions. In the summer, it gets a little bit more tricky to make a clear cut and dry answer as to when you can and cannot avoid icing conditions, and a little bit more thought has to go into it. So while this would seem like one that's easier to handle in the summer, I would say it's almost easier to handle in the winter, as far as avoiding icing conditions go, just from the standpoint of being able to give a clear-cut yes or no, can we avoid icing conditions? Yeah, anytime you have any sort of MEL limitation on a system that is pertaining to anti-ice, you're going to see the limitation: operations are not conducted in known or forecast icing conditions. So again, I mean, we're just talking about a crossbleed valve, something pretty minor, but because that could cause our anti-ice system to be less effective or less functional, we're not going to take the risk of sending this plane into conditions where it could start collecting ice. Anti-skid system. What are the associated restrictions? And there are quite a few with this one. What are the associated restrictions if we're operating with a broken anti-skid system? Who can give me one? Kaylin.
The one that's highlighted is takeoff or landing is not conducted for with a contaminated runway.
All right, cannot take off or land from a contaminated runway. What else? Alan.
You need both thrust reversers.
Both thrust reversers. What else? Lakeisha.
You need both pair of ground spoilers to be
Both ground
opposite.
spoilers. Yep. Yeah, anytime that there is something wrong with the anti-skid system, again, that is what's making sure that our tires maintain proper traction during braking. Pretty much any other system that impacts our braking action has to work. Have to have nose wheel steering. Both pairs of ground spoilers are operated. Both thrust reversers work. Both inboard and outboard wheel brakes are verified operative, which means a mechanic actually has to go down there and watch the brakes. They'll do a brake functionality test. The pilot will engage the brakes and release the brakes, and a mechanic has to be down there watching and reporting to the crew that every set of brakes actually engages when the pilots engage the brakes. Both ICAS brake temperature monitoring readouts associated with the operative anti-skid channel are operative. We see that reduced thrust takeoff operations are prohibited. As stated, takeoff or landing is not conducted from a contaminated runway, and operations are conducted in accordance with airplane flying manual supplement operations with anti-skid and operative. And again, just like we saw with the ground spoilers, that is going to be impacting our accelerate and stop distance and required runway length, and could have associated weight penalties if the required runway length that it's saying that we need is not available. One interesting thing on here is reduced thrust takeoff operations are prohibited. Generally speaking, when we're planning flights, we'll never plan the takeoff unless maintenance specifically requests it. Using full engine thrust, usually they'll do what's called derated thrust, where essentially you're only asking the engines to provide enough thrust to get the plane off the ground, because that helps prolong the life of the engine. However, with this MEL, it's saying you have to use a full thrust takeoff, because again, this is going to be reducing the amount of runway, is going to be increasing the amount of runway required to stop. So it's saying we can't do a reverse thrust takeoff where we're using more of the runway than we otherwise would need to. We need to do a full thrust takeoff so that we can get off the ground as soon as possible. Also, so that those engines are completely spooled up, so that if we do have to abort the takeoff, we have full thrust power available to the thrust reversers. Now let's take a look at that highlighted point. Every single point in here, which we haven't seen in any of the other MELs, pertains to how we dispatch this flight. Every single point in here is something that we will need to consider when we are dispatching. But let's specifically take a look at this highlighted point. Takeoff or landing is not conducted from a contaminated runway. Can anyone tell me what constitutes a contaminated runway? Trevor.
It has to be greater than 25% of a contaminant that's greater than 1/8 inch deep.
Correct. Greater than 25% is covered with greater than 1/8 inch snow, slush, water, etc., or any amount of ice. Greater than 25%, greater than 1/8 inch. That is a definition you should know, the definition of a contaminated runway. That is one that as an operations manager at my airline, I expect the dispatchers to know. I expect the pilots to know. And the number of dispatchers and pilots who do not know what defines a contaminated runway is a lot higher than it should be. And I have experienced this at every airline I have worked at, and every airline role that I have been in, that people do not know this definition. And there are a lot of MELs and performance factors that will state that either you cannot operate to or from a contaminated runway, or you have increased restrictions operating to or from a contaminated runway. And then, for instance, I'll have a dispatcher come up to me and say, hey, I need to kick 25 passengers off this flight because I have a restriction because the runway is contaminated. And then I'll go and look up the NOTAM, and the NOTAM will state 10% of the runway is covered with slush. And that's not a contaminated runway. And then I have to have an argument with the dispatcher or the pilot or whoever it may be about why it is not contaminated per the FAA's definition of a contaminated runway and all performance limiting factors that state a contaminated runway. So from a, not only will you be expected to know this definition when you take your oral exam with the DADE, but from a professional accountability standpoint, you should know the definition of a contaminated runway. Greater than 25%, greater than 1/8 of an inch, or any amount of ice.
Hey, Ryan, does that include stuff like rubber at the approach end of the runway or sand, stuff like that? The contaminants?
If it's greater than 25%.
It covers it, okay.
Yep.
And then for the 1/8 of an inch, that's specifically to like water coverage on it.
Water, snow, slush, dry snow, wet snow, compacted snow, sand, dust. Marbles, whatever it happens to be. So, again, anti-skid system. This will be one of the two that generally is included if there's going to be a conflicting MEL situation. When I've seen it, and I'm not saying these are the only ones that it can be, but usually it's going to be an anti-skid system with a thrust reverser or a ground spoiler or something like that, or it'll be something like an AC pack and a bleed system MEL that can't be combined. Those are usually the two that show up when we're talking about conflicting MELs. As far as like what's going to be on the exam. Again, that's not all it could be, but those are the big two that I've seen. Questions regarding MEL and the anti-skid system or runway contamination, anything like that? Brian.
Is this another situation where we might want to consider the runway length just in case there's any skidding that takes place, or no?
Yeah, and like I was saying, when the computer runs the performance calculations, it'll come back with like if there is a limiting factor, something like that. When we talk about, and this is something that I have found in my experience, both personally and from observations, it takes some actual like real world experience of actually dealing with these kind of things for people to fully grasp, and that's just because it's somewhat of a more it's not such a cut and dry concept. When we talk about like, when we're talking about like what is the max takeoff weight for the CRJ 700, or what is the max landing weight for the CRJ 700, when we're talking about those numbers in the context of aircraft systems, that is the maximum structural landing weight of the aircraft, or the maximum structural takeoff weight of the aircraft. That is saying that all other factors being negated, that's the heaviest the aircraft can structurally handle taking off or structurally handle landing. A lot of times you will have a max takeoff weight or a max landing weight that is lower than what we talk about in this class as your max takeoff weight and your max landing weight. And that's because there is another factor that is impacting that takeoff weight and landing weight. That could be atmospheric conditions, if it's really hot, if it's really humid, if you're at high altitude, or it could be a performance penalty from an MEL such as this one that is saying, I don't have as good braking performance as I would if everything else was functional. And since we're trying to take off from a 6,000-foot runway, or we're trying to land on a 5,000-foot runway, this flight cannot carry all the way up to its maximum landing weight, because in that case, it would be too heavy to safely stop within, the required stopping distance with, its additional 20% and whatnot that we have to calculate. So in that case, you will get a weight restriction when you are doing your performance calculations that is lower than that max takeoff weight, max landing weight that we talk about when we're talking about systems. And that's because in this case, for instance, in order to safely stop the aircraft, it can't carry that much weight. It has to carry, there has to be less weight on board due to the performance restriction, due to the loss of functionality for it to safely stop. So just because the aircraft can structurally carry so much weight doesn't mean that we are capable of carrying that much weight all the time. And that's not one that you'll really have to deal with until you get into like actual on-the-job dispatching, because we're not going to be calculating takeoff and performance data to that degree for this class. You're not going to be expected to calculate takeoff and landing performance data to that degree for your practical. At most, you might be asked, like, what are some factors that might, limit our takeoff weight or landing weight? But beyond that, the expectation to get your dispatch certificate is not going to be complex takeoff and landing performance calculations. That's all stuff that will be handled by computers when you're actually dispatching. And until you really start to experience that, I find that there is somewhat of a disconnect between the knowledge and its application. And there's nothing wrong with that. It's just one of those more elusive concepts that you really have to experience to understand. Questions before we go to break? All right, the time is 2022 Mountain Time. Let's take our last break. Let's come back at 2032, and then we'll do the last hour of class. All right. Let's get through this last hour of class. Weather radar. Here's another fun one. MEL 34-41-1. Weather radar system. What is our restriction? Brian.
Can't if you have a potential for thunderstorms along your route, I guess under IFR and night VFR conditions, then you can't go.
Yeah. So, cannot fly a route where thunderstorms or potentially hazardous weather exists under IFR conditions or nighttime VFR, essentially. Can't really operate around hazardous weather if we don't have a weather radar. Pretty straightforward. This is always a fun one that generally turns into a discussion with a chief pilot or a on-duty pilot or something like that when this MEL comes out. The question that we need to consider this one is, when does night begin? Noah.
Is it civil twilight wherever they're flying?
Yeah, so it would be the end of civil twilight is when night officially begins. There has been a lot of ambiguity with the FAA regarding civil twilight and when night officially begins. A lot of airlines are now changing the way that MELs are worded so that they now say that flights must be operated during the day, because that's a lot more clear cut that day ends at sunset. That way there's no ambiguity, there's no question of when the flight is legal to operate. It's clear cut. At sunset, plane can no longer fly. Trevor.
How many miles would you say is considered a safe distance from this kind of weather for this type of situation?
That really comes down to honestly, that would be discussion that you need to have with your pilot to see what you're comfortable with, what they're comfortable with, etc. Some pilots, they'll go fly visual into and around, pop-up thunderstorms all day. Other pilots won't. So that's going to come down to a discussion between you and the pilot to decide what you guys personally feel is safe. I've been on the jump seat of a flight with an in-operate weather radar, and we were weaving through cumulonimbus clouds. And then other pilots say they don't want to be within, 10 nautical miles. So again, this is one where the language gets a little tricky because it's not cut and dry. There's no, in the MEL itself, there's no clear demarcation line as far as what constitutes, potentially hazardous weather and how close to the thunderstorms can you be? Now, there may be additional information in another manual that would be specific to your airline, but within the MEL itself, there is no clarity. So that would be something that you would need to consider if your airline has other manuals that might provide more guidance in this wording, or if it's a conversation you should be having with your dispatch supervisor, with your pilot, to determine what you believe is safe operationally and within the guidelines given in the MEL. If this comes up on your practical, I just wouldn't route that plane anywhere that could be considered close to hazardous weather. Bleed air, pressure regulating SOV, PRSOV. This is a favorite one for CRJs to fail. MEL 3611-2, Category C, installed 2-1 required. Bleed air is another one of those systems where you're going to have a massive section of the MEL manual devoted to bleed air, just because it is a very complicated system with a lot of parts and a lot of things that can break. So there's going to be a lot of associated MELs for each one of those points of failure. But for this specific bleed air MEL, what restrictions do we have? Michelle.
Operations are conducted at or below flight level 310 for the CRJ 700
Okay.
and at or below flight level 250 for the CRJ 900. Also, operations are not conducted in known or forecast icing conditions.
All right, very good. We have one other in here that we might want to consider besides the two highlighted ones. That would specifically be something that would be a dispatch item. Yeah, Trevor put it in chat. The APU must be operative. So let's look at these other two restrictions. Well, let's start with that one. Why would the APU need to be operative? If we had an MEL on a bleed air system, why would the APU need to be operative? The APU just is a power generator, right?
And also supplies bleed air.
It is also a backup source for bleed air. Very good, Christopher. So we have something wrong with our bleed air system. We want to ensure that our backup bleed air system is available to us. The APU must be operative. All right, let's look at the next one. Operations are conducted at or below flight level 310. Why would we have a flight level restriction on the bleed air system?
It's the APU restriction.
Yeah, that would be APU restriction. Also, because yeah, APU has to be at or below 310 to be started. Also because bleed air is what runs the AC packs. And so if we are limiting the availability of bleed air to the AC packs, once again, we don't want to overstress them. And so we're going to keep them at that lower altitude. Lastly, operations are not conducted in known or forecast icing conditions. This isn't an anti-ice MEL, so why would we not be able to operate in icing conditions? What system is used to provide anti-ice protection to the leading edge of the wings and the engine cowls? Yeah, Trevor put in chat, bleed air. We use bleed air to keep for anti-ice protection on the leading edge of the wings and the engine cowls. So if, once again, if there is an issue with the bleed air system, that would reduce the efficacy of our anti-ice protection. So therefore, we do not want to operate into icing conditions if we cannot guarantee 100% performance of the anti-icing systems. Questions about that bleed air MEL or any of its related restrictions? All right, APU, our auxiliary powered unit, APU MEL 49-10-1-alpha. Who can tell me how many are installed and how many are required? Michelle.
1 is installed, 0 is required.
Very good. Yeah, we have one APU. We don't need it, per se. What operation restriction is stated in this MEL?
Both IDGs operative.
All right, very good. Both IDGs are operated. So, you know, as long as both IDGs are operative, could we dispatch an aircraft with an inoperative APU if the constant speed drive was broken? Trevor says no. Everyone agree with him? Yeah. So if we look at that note, it says the IDG is considered inoperative when either the generator, GCU system, or the constant speed drive is inoperative. So even if there isn't specifically an MEL for the IDG, if there were an MEL for the CSD, we would still have to consider the IDG inoperative, since the CSG is what is actually physically spinning the IDG. So therefore would not be able to dispatch with an inoperative APU and an inoperative constant speed drive. Now, so we have that clear-cut restriction there in the MEL itself. But what other factors would we need to consider and provide for if we were dispatching an aircraft with an inoperative APU? Thinking about what the APU does for us, what it does for the aircraft. What else would we need to consider and make provisions for if the APU didn't work? Lakeisha.
I'm thinking like alternate ground power.
Yep, definitely going to need ground power because we're not going to be able to generate power on the ground with the APU. What else? Ground power and one other big one that go hand in hand with an inoperative APU. Michelle.
The jet bridge power.
That would be a source of ground power. So you would either have like a generator that you'd hook up, or there would be a shoreline connected to the jet bridge. So one or the other would be providing alternate ground power. So if we think about the functions of the APU specifically on the ground, we've covered its function as a generator. What is the other thing it does for us on the ground?
An AC unit.
Yeah, air conditioning would be good. Somebody was just put in chat. Let me see if I can pull that up. Go away. Yeah, so Betty Sue said provide electrical power, which we have discussed. Air conditioning would be probably good, especially in the summer. But the big one is going to be the APU gives us bleed air to start the engines. If we don't have a functional APU, we need an alternate method to start the engines, and that would be an air start. So along with ground power, we would need to ensure that each station that we are dispatching the aircraft to has a functional air start. Now, depending on the way that your airline is set up, that might be something that you as the dispatcher need to ensure is available by directly contacting the station, or that you would need to talk to someone like a system controller or a tail router or a sector supervisor to ensure that they have reached out to the station to confirm the availability of an air start or ground power. Because again, if we go, and the same thing like for alternate planning, if you are dispatching an aircraft with an inoperative APU and that flight requires an alternate, you would want to ensure that your alternate has operative ground power and air start. Because again, if we refer to what makes an aircraft suitable, it has to have the appropriate handling equipment for the aircraft. If the aircraft requires ground power and an air start, appropriate handling equipment includes ground power and an air start. If you dispatch a flight and it diverts to its planned alternate, and you didn't plan an alternate with ground power and an air start for an aircraft with a deferred APU, you're going to look a little foolish and probably be writing an ASAP report as to why an aircraft got grounded after diversion to a planned alternate when it had a known APU deferral. So that's going to be the big one. Again, with it being the APU, it being a generator, anytime we have a deferral on the electrical system, we can't have any other deferrals on the electrical system. So if the APU doesn't work, the IDGs have to work. If the IDGs don't work, the APU has to work. Can't be both. And then the other one, that's always associated with an APU, and if you're dispatching planes, you're going to be dispatching a plane with an inoperative APU. They are small, they are fragile, they break. Guaranteed within your first week of dispatching, you will dispatch a flight with an inoperative APU. And when we have an inoperative APU, ground power, air start required. Now, whether it is your responsibility as the dispatcher to directly contact the station, or your responsibility as a dispatcher to ensure that somebody has contacted the station, either way, you're the one signing off on the flight. It's your name on the dispatch release. You are saying that you ensured whatever method is used by your airline, that when it gets where it's going, there is going to be ground power and an air start, or it's going to be fixed. Otherwise, you're sending that aircraft off to Springfield, Illinois, where it's going to get stuck, and you're calling out a maintenance crew from Muncie, Indiana, because you didn't pay attention to your MEL restrictions and the related performance requirements for an inoperative APU. Not that I have seen that specific instance happen before or anything. So even though it's not stated in the MEL, this goes back to what I was saying earlier. The reason why it's critical for you as dispatchers to understand these systems, understand what they do on the airplane, and understand what happens when they don't work, is because even though in the MEL description it says nothing about needing an air start and ground power, you should know that if your aircraft has an inoperative APU, it needs an air start, it needs ground power, or else it's going to be dead on the ramp when it gets where it's going. Questions about APU deferrals? All right, those are all the examples that I have in my PowerPoint when we're talking about other terms related to maintenance. By the way, I should clarify, earlier on this one, I put in the title of this slide, WX radar. WX means weather. If you ever see the abbreviation WX, that means weather. DX is dispatch. So if you see the abbreviation DX on anything, that is referring to dispatch. MX is maintenance. So here we see other MX terms, so other maintenance terms. You may hear someone refer to something as a camel. And you're probably thinking to yourself, there's no way I can put a camel on a CRJ 700. It's just not big enough. Well, in this case, CAMEL stands for Crew Applied MEL. CAMEL. And what that means is, generally speaking, when maintenance control is trying to defer something on the aircraft, an actual licensed aircraft mechanic, someone with their A&P, has to go out to the airplane, confirm what's going on, do a write-up in the aircraft maintenance log, and apply the deferral along with whatever other procedures we saw in those MEL cards for maintenance procedures. That's where they're looking. Now, generally, most of the time, an actual mechanic has to go out and do that. Now, there are certain maintenance items that the airline may define are of a nature that they do not require a mechanic to come out and sign them off. It's something that maintenance control can just talk the pilot through, and the pilot can put in the associated logbook entry and apply the MEL themselves. APU deferral is a big one that you'll often see as a crew applied MEL. APU defers after pushback. Captain calls in, Ask maintenance control, do I need to come back to gate? Maintenance control says no, this one's a camel. You just need to write this up in the logbook, pull a sticker out of the maintenance can, put it on the associated system, and we're good to go. So crew applied MEL, CAMEL. A lot of times people just say it's a camel. And all that means is the pilots can apply it. They don't have to actually have a mechanic come out and work on the aircraft. It's just a routine system that can say, whatever, we're just going to defer it. It doesn't work. Here are your operation restrictions. Sign off on it, Captain, and we're good to go. Talked about this very briefly at the start of tonight's class. An NEF. NEF is non-essential furnishing. So this is going to be something on the airplane that can be defective or broken or missing or not functional, that really has nothing to pertain to the safety or operational, applicability of the aircraft. An NEF would be something like the carpet is torn. There is a wall panel that fell off. The coffee pot handle is missing. The lock on the lavatory door doesn't activate the light. Something like that. Something that is supposed to be a certain way on the airplane, but is damaged or defective in some manner, but doesn't impact the operational reliability or safety of the aircraft. It's going to be some trivial thing, like I said, like the carpeting or a wall panel or something like that. Now, a little food for thought. Let's say that the ashtray in the airplane lavatory was damaged. Do you think that would be an MEL or an NEF? Sam says NEF. How's everyone feel about that? Ashtray in the lavatory. Is that an NEF? Lots of thumbs up. Oddly enough, that would be an MEL. Yep, Nichelle said MEL in chat. Lavatory ashtray is an MEL. FAA requires that every airplane lavatory be equipped with a functional ashtray. And that is because they know no matter how many regulations they slap on these flights, someone's going to go in that lavatory and smoke. And when they do, there needs to be a safe place for them to dispose of the ashes. And this came after somebody threw away a cigarette into a lavatory trash can and caused the plane to catch fire and crash. So it is now an FAA requirement that every aircraft lavatory have a functional ashtray. If that ashtray is not functional, that lavatory cannot be used. The entire lavatory has to be taken out of service. But generally speaking, little trivial items that otherwise would not impact the operation of the flight would fall under that NEF category. Non-essential furnishings. ACI, administrative control item, not something you really need to worry about. You may hear it brought up when maintenance control is talking about stuff. That's going to be something on the airplane that, again, isn't really going to impact its legality for dispatch. There might be some sort of deviation that's put in on the back end of its performance calculations or something like that that you will never see as a dispatcher. It won't be on the flight release. It won't be something that's visible to you on a day-to-day dispatch basis. It's just going to be something on the aircraft that is being tracked, but doesn't affect the dispatchability of the aircraft. ACIs and NEFs do not appear on the dispatch release. Mic is off. Oh, okay. Stupid computer. NEFs and ACIs will not appear on the dispatch release. MELs and CDLs will. One thing you'll probably see in this lovely world of computers that we deal with is often enough for it not to be uncommon. I would say either an MEL will have been applied to an aircraft and it not show up on the dispatch release, or an MEL will show up on the dispatch release that has been cleared from the aircraft and is no longer applicable. And it's a technology thing and it's a hassle, but it is also one of the reasons that we need to be double checking all of the MELs that we are planning against all of the MELs that show up on the dispatch release. Because in this lovely world of computers, sometimes things just kind of get lost in the matrix. Brian.
So is that something that the flight crew double checks? All the
It'll be
MEL?
something. Yeah, it'll be something they could see. It'll be something you might see. Sometimes a crew might call in and say, hey, this MEL is on your dispatch release, but it's not in my logbook. Or they'll say, this MEL is in my logbook, but it's not on the dispatch release. Or you'll be planning a flight and you'll see, this MEL is on the aircraft, but it's not on the dispatch release. Or vice versa, you'll say, this MEL is on the dispatch release, but I don't see it on the aircraft. But if that's the case, now there is a discontinuity in the flow of information, and that has to be corrected before that flight would be legally able to be dispatched. And you'll just have to address that with whoever controls those systems to ensure that it is handled appropriately. Whether it's something that needs to be removed or it's something that needs to be added somewhere. And since you're not the person who is controlling the maintenance side of the aircraft, that has to go to someone who is, because you don't know if it's something that should be there that isn't there, or it's something that isn't there that should be there. But everything needs to line up between what is applied to the aircraft and what appears on the dispatch release. A lot of times you will see in if you're reading through, especially like in maintenance procedures and stuff, or you might see in the description of an MEL that it can be applied for 5 flight cycles or something like that. It's like, or you might overhear someone talking in the OCC saying, yeah, we can apply that MEL for X number of flight cycles. A cycle is engine start, takeoff, touchdown, engine shut off. That is a full cycle. When we talk about flight cycles, that is what constitutes a cycle. And last term I want to mention is speed tape. If you are not intimately familiar with the lovely world of aircraft maintenance, you may not be familiar with what speed tape is. Speed tape is an aluminized tape. If you've ever done any HVAC work, it's similar to HVAC tape and will slice your hands up just as much. It is not meant for holding structural components together. Speed tape is applied to basically smooth out areas, to restore the aerodynamic properties of a part of the aircraft. If you'll probably hear, oh, we'll just put some speed tape over it and we'll be good to go. Well, what they're doing is usually that's going to be some part of the aircraft that there is no longer a smooth aerodynamic flow. They're putting speed tape over it to restore a smoother aerodynamic flow, and then continuing, or they're doing it to protect an area from disturbance from the air, something like that. It's not a structural tape. It is simply there to ensure that air flows a specific way. And when you see those YouTube videos like, oh my gosh, they've duct taped the wing on, it's like, no, that's not duct tape. That is speed tape. That is there to provide aerodynamic efficiency, because there is something wrong, or it's covering a seal that's missing, or it's covering a seal that's curing, and they're like, oh, well, the seal can continue to cure as long as we have it covered with speed tape. Noah.
Okay, I could be remembering this wrong, but I did a job shadowing day with Breeze, and the guy shadowing, the pilot called him and said, hey, we have like this thing that's loose on the plane, and we can tell that passengers are concerned. Is it okay if we just put speed tape on it so it doesn't like rattle or anything throughout the flight? Is that something, because you were just saying it's mostly for aerodynamic purposes. Do you see that a lot where something's maybe loose but isn't required for it to be legally dispatched? So they just put like
usually that would be like if there was like two panels that were coming together and one side was loose, they just speed tape over it to hold them down. They're not holding it on. They're just keeping it. I mean, it's flopping around because of the way the air's hitting it. So they're putting that tape over it just to hold it in place.
Okay.
You'll see that again over seams, over seals. They can make fairings out of speed tape. They can cover broken parts or dents and things like that with speed tape. We had a great one recently. A ramper drove the belt loader and punctured the engine cowl with the railing of the belt loader, and it was hilarious because you look at the puncture and right above that is a sign saying caution, don't hit this with the belt loader. And yeah, you look at, and I sent out the ferry flight paperwork for it, and the paperwork said, yeah, cover with 5 layers of speed tape and you're good to go.
And then cover that message with speed tape.
And then, yeah, we're like, we just need to put a target there, and then we can score them on how close they get to it. All right, questions about MELs, about how they impact how you dispatch flights, how they impact legal to go, anything like that. What do you guys got? Now's your chance to ask it. Or when I see you tomorrow. But now is your chance to ask it. Brian.
So are there, I mean, is there in the real world, I mean, software that kind of helps you kind of manage like, in other words, stuff that can detect conflicting MELs, or stuff that can, notice like what, we got to stay below the certain flight levels, things that can kind of confirm things and check, or is it all still a manual checking by the dispatcher?
No, a lot of that is automated from the maintenance control side all the way up to generating the dispatch release. For instance, if you have an MEL that has a performance restriction or a flight level restriction on that, a lot of time, like, the software won't even let you plan the flight above 310. Or if there's a performance restriction on that, when you go through to do your takeoff and landing calculations, all you need to make sure is there'll be a box somewhere on there that includes that MEL. Just make sure it's actually checked, and it'll run properly, and it'll take that into account. Again, a lot of this is just obviously, you know, when you do it for your practical, no, there's no computer that's going to help you because everything we do for the practical is pen and paper. But real world dispatching, yeah, the way that these systems are set up, they automate a lot of these processes. Like on the maintenance control side, they can see immediately if, you know, what they're trying to do conflicts with something else that's wrong with the aircraft. And they'll usually just go ahead and do it because they don't care. And then they'll say, oh, by the way, I just took out the anti-skid system and the thrust reversers on this airplane. Have fun. And then I'll have to sit there and bang my head against the wall while I try to figure out how to swap aircraft. But yeah, real world, the computer is doing a lot of that, but you still have to double check it because the computer can make mistakes.
Yeah, absolutely. Cool.
You know, boxes might not get checked. There might be a coding error that caused it not to flag the specific, you know, performance restriction. Yeah, and yeah, so you're just making sure, and like I said, like a lot of times, I should say a lot of times, but you know, often enough that you will experience it at some point. There's going to be something's not going to flow from one piece of software to the other piece of software, no matter how integrated they make all of these systems. There's going to be a discontinuity at some point when you are dispatching where something's not going to match up between what's shown on the aircraft and what's shown on the dispatch release. And so being aware of when that happens, because, you know, if you were to dispatch that flight, now you've dispatched an illegal flight. Because you don't know if what's shown on the aircraft is accurate or what's shown on the dispatch release is accurate. So making sure that those pieces all line up is a big one that you will experience in the real world. And then, like, for instance, I think they eventually automated it, but it wasn't while I was still actively dispatching at Breeze. But like if there was an MEL that required the APU to be running in flight, when I was doing my fuel planning, I had to make sure that I opened the correct drop-down menu and actually manually selected APU on, so that it would calculate the fuel burn for the APU operating in flight. And even still, like from my perspective, like any time that we change the weight and balance figures for an aircraft, we still have to go in and adjust all that information manually in the computer systems. So a lot of it's automated, some of it still isn't, and even what is, you always have to double check because it could still be wrong. I mean, if all these systems worked flawlessly, the computers would just plan the flights from start to finish, and there would be no need for dispatchers. But in my opinion, I think dispatchers are going to be around longer than pilots, personally.
That's part of why I'm here. I'm a former software developer, so this is a big shift for me. But I know you verify because there's plenty of bugs in production systems. So yeah, it's funny. Who you're shadowing? Who were you shadowing with at Breeze? Do you remember? Oh no, that wasn't me.
Oh, okay, sorry.
That was Noah, I think.
Yeah, that was me.
Okay.
Yeah, I was.
Yeah.
His name was Daniel. I don't remember his last name.
Okay. I know Daniel. Yeah. Anyway, like at Breeze, they like to advertise that they have this really big like technology development department, but somehow none of that ever makes it to the dispatch side. So we had a dispatcher teaching themselves programming so that they could adjust like the back end coding on some of the systems, because the IT guys just, I mean, they were all focused on making the app work better and adding a different button to the website, as opposed to actually making sure like the dispatch systems worked the way they were supposed to.
Yeah, that's part of why I don't do software development anymore. It's because of the decision makers.
Yeah, no, it's like, oh yeah, we'll get to that. And then it was like, but first we have to make these 3 upgrades to the app, and then we're going to change the way that the ticket printers function, and then maybe we'll get around to fixing the dispatch software. It's like, really, this is our priority? So, but yeah, making sure that we are double checking all of these things to ensure that the proper restrictions are being applied, that the proper legalities are being adhered to, and especially the big ones, like when you're talking, like obviously something like a flight level restriction, that's an easy one for the computer to quickly say, oh yeah, I'm just not going to plan this flight above 310. But even then, if you're talking about like a long haul flight, if you're an airline that's doing like coast to coast flights or international flights, and suddenly it gets slapped with a flight level 310 restriction, that's going to be like, if you're talking like you're doing like New York to LA, that's a 5 to 6 hour flight. That's going to be a pretty significant fuel penalty over the course of that entire flight. You may end up weight restricted because of how much fuel it takes to fly at 310, as opposed to you wanted to fly it at 390 or 370. And now you're looking at bumping packs or bumping bags, or you're limited on your alternate selection or something like that. Whereas even though the software is doing the calculation for you, there is another aspect that isn't as black and white, isn't as clear cut, isn't spelled out right in front of you, that you still have to consider as the dispatcher to ensure that that flight is properly, safely, and legally planned. And then you talk about the ones like no flight into icing conditions. Well, now you have to review forecast models and temperature ranges and, you know, moisture and humidity charts and convergences to make sure that you're, especially in the summer, to make sure that that route that you've chosen isn't going to take that plane into reported or forecast icing conditions. Nighttime MEL restrictions, things like a nav light, you know, something as simple as an LED on the tip of the wing being burned out. You have to make sure that your flight lands before sunset. And you know, you planned your flight, and okay, yeah, it's going to land. I show it landing 25 minutes before sunset. So just, you know, tell the pilots, like, hey, by the way, you have this MEL. You know, you need to make sure you landed by sunset, blah, 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 blah. Good to go. Send it off. And then you start planning your next flight, and then you get, slapped with, you have a flight that's holding, and then you get a call from a pilot for a possible medical emergency, and then suddenly you've missed the fact that your flight that had to land before sunset ended up getting delayed for a missing bag by 20 minutes, and it just took off, and now it's going to land after sunset. So that is where the role of the dispatcher comes into, with ensuring that we are aware of MEL restrictions, that we are aware of the associated legalities, and that the flights are being planned and operated within those restrictions and legalities. And that's where, it can't all be done by automation and computers and tracking and software, where, as fallible as we are as humans, we still do a better job than the software when it comes to these decision-making processes and monitoring processes that aren't clear-cut black and white, can be described in a few lines of code or a few sentences, decision-making processes, where it takes some critical thinking. It takes thinking through what other considerations go into this specific MEL. Like if we go back to, what was a good one? Like an ACARS outage, you know, we can say all day and night, great, ACARS is out. We need to make sure that the pilots know to monitor AirInc. But are you also monitoring AirInc? Did you remember to have the volume turned up on your phone so that if the pilots try to call you, you know to answer? Or are you sitting there listening to your music and you don't hear the call and another dispatcher takes the call for you and now they're calling you out because you missed an AirInc call from your flight? So being engaged, knowing what's going on with your flights, knowing what restrictions they have, making sure they're not just planned legally, but they're also continue to operate legally. That's where our role of dispatchers comes in largely, where the software and the computers and the automation ends. Tatum.
So I know we just looked at a bunch of MELs. Are CDLs anything we'll look at for dispatching our flights? Or are we
We're not going to look at any CDLs. They're going to be similar. With CDLs, a lot of times that's just going to end up being a performance restriction that is handled by the software. You won't see any in this class. You won't see a CDL in your practical. You'll need to understand what a CDL is. They'll look very similar to an MEL, but usually it's going to say something like, you know, CDL applied for dent to right-hand spoiler, 5% increased fuel burn penalty applied.
Okay. Gotcha.
And then you'll just be double checking to make sure that the software actually ran the flight with a 5% increased fuel burn.
Okay, thank you.
Yep, good question. Trevor.
How often do MELs hit their maximum deferral time period? Like, is that a big issue? Also?
Daily. With how heavily airlines will fly the planes, because again, I mean, we're talking multi-million dollars investments for a single aircraft. If it's not flying, it's not making money. So, and this is a huge argument that you will hear brought up by maintenance controllers, is that they're flying the planes too hard. And yeah, they probably are, but you know, some bean counter somewhere has figured out, you know, how hard they can fly the planes and still take some hit on the maintenance side, but you know, make it the most profitable. But a lot of times, yeah. And again, this usually won't be an issue that you'll have to deal with as a dispatcher, because hopefully the tail router or the system controller or the sector supervisor or whoever is doing it at your company has taken into account the fact that this aircraft has a drop dead MEL on it. And that's the term you'll usually hear. It's called a drop dead MEL. That's an MEL that ends either at the end of the Z day or the end of the operational day, depending on how the MEL is written. Hopefully, whoever is doing the routing of that aircraft has taken into consideration the fact that that aircraft has an MEL that will expire at the end of the day. But you will regularly see MELs on aircraft that are flown all the way up to their limit. And then usually, even then, a lot of times maintenance control will get an extension on it.
So is that something where, like, if you are at the end of your time period, that you try to get an extension before you swap to a new plane, or?
I mean, that again, that's going to be something that's handled by maintenance control on how they, because again, as dispatchers, we're not trained to understand that when we can and can't. We don't learn the legalities of that. That's something that they learn when they're going through their maintenance school. We would defer to them. But what you would want to be aware of as a dispatcher, you have an MEL that expires at midnight Zulu. And because of some strong headwinds, your flight is now scheduled to land at 0002, 2 minutes after midnight Zulu. So now you need to address that, with the duty manager and maintenance control saying, hey, we have this MEL that expires at midnight Zulu, but my flight's not going to land until 2 minutes after midnight, and I have no way to speed it up further. So what's your plan to do with this airplane? Because right now it's not legal to dispatch.
Got it.
All right, class is officially over for tonight. I will be on for a while if you guys have additional questions. Otherwise, have a good night, and I will see you tomorrow.
Thanks, Ryan.